Hello all my dear students. So I welcome you to Chendu biology classes. I hope your preparation is going well for your IIT JAM as well as GATE Excel preparation. So now today we are going to discuss one of the very important topic of your IIT JAM as well as GATE Excel syllabus related to chemistry. So the topic here is general organic chemistry. Okay, so if you are thorough with this one particular topic, you can able to survive or you can able to gain many many different type of chemical reactions. You can easily solve them even without knowing their name of the given reaction. So but what you are going to study here, complete concept regarding these organic reactions. Okay, so once if you are clear with this, even if you don't know the name of that particular reaction, you can able to do the chemical reaction using the concept of this general organic chemistry. I hope, I request everyone to watch the video till the end so that you will get some clarity over this topic. Okay, so only on this particular topic I am going to cover three sessions so that you will get complete idea. So at the finally you will be feeling like you are a chemistry student itself. Okay, so that is why that is what my intention is to be. Okay, so now let us start the discussion of this general organic chemistry. Okay, so here what exactly a chemical reaction is. So in a chemical reaction we will be seeing, so what we are going to see in chemical reaction we have something called reactants. Okay, so reactants gives rise to some products we are saying now. So during this process, so this reactant side we have two things. One is called substrate and another one is called reagent. Okay, so what I am saying, just listen here for a few more minutes so that you will get some clarity. Okay, just give me some time. Yeah, so what I am saying, reactant side we have substrate and reagent. Okay, so this reagent also, for understanding purpose I am saying attacking reagent. So now what you can say, this reagent will attacks on this substrate. Okay, so therefore reaction will starts here, reaction initiation takes place. So now what happens, when reagent attacks on the substrate, we can expect something called intermediate. What is that? Intermediate, or sometimes in some reaction there is something term called transition state. So this will be formed. So finally from this intermediate or transition state we are going to get a product. Okay, so this is our final product. Along with that product we may also get some byproducts also. Okay, so this is about the general construction of a reaction. Okay, so during the reaction we are using some specific condition in order to get product in the major quantities. Okay, so for that particular reaction there are some specific conditions. Okay, some reactions are favorable by some particular temperature and some particular pressure. So that will be mentioned over this arrow mark. Okay, so something like temperature, some room temperature or some 25 degrees Celsius or something like that, specific temperature and pressure will be mentioned here. And you know, if you are heating this reaction you can use a delta symbol here. Okay, and if the reaction is taking place in presence of sunlight, you can use something like H nu, indicates sunlight or some particular frequency you are using here. Okay, this is what the general indication. And some reactions are very slow right now. So in order to speed up these reactions, we will be using something called catalyst. Okay, so catalysts are of two types, negative and positive. So positive catalyst generally increases the rate of reaction, negative catalyst decreases the rate of reaction. So that catalyst also you should be indicating on this arrow mark. This is a general representation of given chemical reaction. I hope you got the general construction. Okay, so now by understanding what exactly reactant product intermediate is forming, we can expect what kind of product is going to be yield from that. Okay, so everything regarding these things we are going to discuss. What kind of substrate we have, if a particular kind of substrate is there, so what is the kind of reagent we should take here so that this reagent go and attacks this substrate. Okay, now understanding the characters of substrate, we can decide what kind of reagent is suitable for that reaction. Okay, so just hold on and follow the class, therefore you are definitely going to get the complete clarity over this general organic chemistry. So here what we are going to do, see the detailed study of stepwise description of a reaction like electron movement. So generally during the chemical reaction what happened here? So what I told you, electron movement, reagent will go and attack. By what it will attack? So the electron, whatever the electron density is there, using that electron density it may attack on the substrate, or maybe this may be electron deficient, our substrate may be electron rich. Now this is rich now, electron rich now, so it will be donating electrons to this deficient one. So finally what we are seeing, just electron movement is taking place during a chemical reaction. Okay, so that electron movement and energetics. So what is the energy changes here? During the bond breaking and bond formation. Okay, and time, details of time required for these steps. Okay, so complete these things comes under what? Reaction mechanism. We will be studying it as a reaction mechanism. Okay, so now here, so now for example I have a reaction here. Reaction is taking place between this like I have something like AB. Okay, okay, let us understand, let us take one molecule itself, methyl chloride I have. Okay, so methyl halides or methyl chloride I have. Okay, so now I am saying you to prepare some alcohol, methyl alcohol I want to prepare. Okay, so now what we need to prepare? Methanol, methyl alcohol we need to prepare. This is our product. Okay, so in order to prepare this, we need to use something that should generate OH group in the place of Cl, right now. So now here I can use some basic condition like aqueous NaOH, something like this, aqueous NaOH like this. So now what happens? See, chloride ion, see, it is very easy, organic reactions are very easy once if you are clear with the concept. Simple, look at here, we have studied that carbon and chlorine, which is more electronegative? Chlorine is more electronegative. So the bonded electrons are taken towards which side? Chlorine side. Yes or no? Right. Now what about this carbon now? The bonded electrons are taken by chlorine. So carbon is getting what charge here? Positive charge, because losing the electron, so that it will generate a partial positive charge on carbon and partial negative charge on the chloride, right now. So therefore, since the positive charge is there on the carbon, now I can say carbon is having electron deficiency. Okay, therefore this OH minus ion, having OH minus ion I am saying, negative charge is there now, so this will go and attack at this carbon. So now what happening? So chloride ion is going out as Cl minus and OH minus is coming in, right now. So now like one is going out, one is coming in, so now I can say our product is methanol is formed here. Okay, so this is a simple example of substitution reaction. One chloride ion, one group is substituted by another group. Okay, so I am going to explain all this reaction very easily. You can able to follow this. I hope everything will be goes well if you follow the class. Now what I am going to explain here, see, in this case if you observe, the carbon chlorine bond is breaking with one side. This electron, the pair of electrons in the bond is moving towards one atom. So this kind of breakage is called heterolytic cleavage. What is that? Heterolytic cleavage. See, during the course of reaction, some bonds are broken and some new bonds are formed. See, this carbon chlorine bond is broken and carbon oxygen bond is formed, right now. So during the course of reaction, some bonds are broken and some bonds are formed. Okay, so now the bond breaking is of two types. How many types? Two types. So bond can break like heterolytically, like one side, depending upon the electronegativity difference, it will breaks. Okay, so now whenever we have different atoms like AB atoms are there, okay, if electronegativity of B is more, electronegativity of B is more than electronegativity of A. In this case what happens? The B atom electronegativity is more, that will drag the bonded electrons towards itself and gives us A plus B minus. So this is heterolytic cleavage only now? Yes, heterolytic cleavage will give this type of species. Okay, now whereas homolytic cleavage means what? I have a substrate like AA type. Okay, this is our initial substrate. Now what happens? So electronegativity of A and A are same, right? So therefore there is no polarity. Okay, therefore what happens to this bond? The bond will breaks into two equal halves like this. Okay, so now what we are going to get? A dot. This dot indicates what? One electron of this bond. Bond contains 2 electrons now. So one electron is going with one A atom and one more as with the another A atom. So that we can get 2 A dots. Okay, so you should not say this as dot, you should call them as free radicals. What is that? Free radicals. Okay, when homolytic cleavage taking place, we are going to get free radicals. Okay, so when this homolytic cleavage takes place, generally when the substrate, the given substrate or given species having electronegativity is almost the same, and this will be happens in presence of some sunlight, okay, or specific frequency is required. Okay, in this case we will get free radicals like this. Okay, I hope you got two things, one is homolytic cleavage, other one is heterolytic cleavage. Okay, yeah, homolytic cleavage generates free radical, whereas heterolytic cleavage generating one cation. See, positive charge is there, so it is cation, and another one is having negative charge, anion. Okay, so these are the two things are formed here. Okay, hope up to here it is clear. Yes, let us move forward with few more terms to be understood here. Okay, so now here if you observe in the previous case what I told you, if I have AA type, so upon passing some sunlight we are going to get some A dots like this, free radical I told you, FR. Okay, so free radical we got now. So here if you observe what is the way I have represented, like this I have represented. So when one electron movement is there, you should indicate with single head arrow like this, like a fish hook. Okay, and if it is something like this, AB type we have, so now electronegativity of B is more than electronegativity of A I am saying, so bond cleavage is like this. I am using double head arrow. So double head arrow indicates what? Both the electrons are moving towards one element, like B element here. So it will be B minus A plus. So this arrow indication is also very, very important. Okay, yes. Next, here I have, here if you see, we have something like free radical we got, here we got positive charge, here we got negative charge. Now we are studying about organic chemical reactions right now. So organic chemistry will be associated with what? Carbon and its compounds. Generally what is that? Organic compounds are associated with carbon and its, like carbon, hydrogen, and sometimes heteroatoms like oxygen, nitrogen, sulfur may also present, but generally it contains what? Carbon and hydrogen right now. So now carbon with one dot, I mean carbon having one electron, so what is that called? Free radicals. For example, I have something like methyl radical, this is, okay, so I should call this as methyl free radical. Okay, if carbon is having like this positive charge, for example methyl chloride you have seen now, here methyl chloride you have seen, so what we are going to get from here, if we polarize like this, we are going to get methyl carbocation right now. So we are going to get carbocation. Okay, so carbocation means carbon with positive charge. Okay, next one more thing is like negative charge also there. In that case what we should call, this is cation, this is anion, right? So we should call carbon with negative charge as carbene anion. Okay, so now one more species formed is carbene anion like this. Okay, so it will be having C minus like this. So this is like CH3 plus methyl carbocation, and this is methyl radical, and here one more example, methyl carbene anions. Okay, so like this you should understand. So these three things are formed by cleavage of this bond. Okay, so what you have seen, reactants will be there like this, reactants will be there like methyl chloride, here you have seen this, it is breaking like this and forming some products right now. So what is this? During the reaction substrates, products are there, between that I told you that maybe intermediates or transition state is obtained. Okay, so now these species are called, what is that? Reactive intermediates. During the course of reaction these things will be formed as reactive intermediates. So what are these? These are reactive intermediates. Okay, carbocation, free radical and carbene anion are the important reactive intermediates. Along with this, there are some other type of intermediates also. I will explain that. First of all, we will understand these basic things first. Okay. So, what are the types of intermediates I have given? What are the types of intermediates I given? Carbocation, carbon anion, free radical. Okay. Let us study the geometry, the structure of these intermediates first. Okay. Then we can able to understand their chemistry and their reactivity. See, carbon intermediate, a carbon intermediate which contains 3 bond pairs and a negative charge on it. It has how many electrons? Valency electrons are 8. Okay. For example, I am saying methyl carbon anion. So it means like this, 3 bonds are there here with one negative charge, like 1 bond, 2 and 3 bonds. See how it is, like 3 sigma bonds and 1 lone pair. Negative charge is nothing but a pair of electron, non-bonding electron. So totally 1 negative charge or 1 lone pair, 3 bond pairs. So 3 bond pairs plus 1 lone pair. What is the hybridization we are going to get? 3 plus 1, 4 now, 4 means what? sp3 hybridization. So what is the hybridization? sp3. Okay, sp3 hybridization, 4 hybrid orbitals are there. So 3 are with bond pairs, 1 is with lone pair. So what is the geometry? It will look something like this, like similar to ammonia structure. Okay, so what is the shape I should call? What is the structure I should call for this? It should be pyramidal. What is that? Trigonal pyramidal. Okay, what is the geometry or shape of the molecule? Trigonal pyramidal. And what is the hybridization of carbon anion? It is sp3. Remember these points, very very important. Okay, and you can say carbon anion is isoelectronic as well as isostructural with ammonia. Isoelectronic means same number of electrons. Isostructural means same structure as like ammonia. Okay, so these terms also they may ask in the exam. Okay, so just for some time you just forgot that you are just a biology student, you just feel like you are a chemistry student, you are learning chemistry. Okay, so that you will get complete idea over this. Yeah, so the next one is like carbon anion we have studied. So how these carbon anions are formed? See, partial formation via Grignard reagent. What is this Grignard reagent? Have you ever heard this word? Yes. So Grignard reagent is, just remember, I am representing whatever the alkyl groups are there, I am generalizing it as R, Mg. Mg means magnesium, and like halogens like RMGX. This is the general formula of Grignard reagent. For example, I am saying methyl group I have, and one magnesium I have, and one bromine I have. Methyl magnesium bromide. So we know magnesium is a second group element, alkali earth metal. What I am saying, it's a alkali earth metal, means metal. So metals are electropositive. What is the positive charge for this magnesium? It will be releasing 2 electrons. So that's why +2. We know bromine, halogens are monovalent. They require only 1 electron. They will take -1. Now how much it is? +2 -1. So carbon is more electronegative than this magnesium, right? So another negative charge should be on this carbon. So overall molecule is neutral, -1 +2 -1. So it will be +2 -2 0. So overall molecule is a neutral one. So see what the carbon is having now. What is the charge on it? Negative charge. So it can be a methyl magnesium bromide or propyl magnesium bromide, ethyl magnesium bromide, or anything, but there we have a carbon. Carbon with a negative charge should be considered as carbon anion. Okay, so partial formation via Grignard reagent. Okay, and formation from carbonyl compounds. What do we mean by carbonyl compounds? See, carbon having C double bond O. This group C double bond O should be considered as carbonyl group. Okay, so now to this, here I am writing methyl group, let us say, and this side one more atom should be there, because what is the valency of a carbon? 4. So 3 only written. So let us say I have one more here, hydrogen. 4 is over. So now when I treat this with some base, okay, base. So what this base will do is, it will abstract a proton from this position. Why this position I will explain later. Okay, now just understand, just remember a point. The alpha, see this is carbonyl group now, adjacent carbon is called alpha carbon. So these alpha carbon hydrogens are highly acidic. Okay, if they are acidic, the base will take that proton. right now. So therefore what we are going to get, only it will take H plus, not electron, okay. So what we are going to get, C double bond OH, this will remains undisturbed, but from here we have carbon, out of 3, 1 hydrogen is removed as a H plus, so remaining bonded electron stays with the carbon. So now carbon is having which charge? So it is a carbon anion, right now. So like this you should understand, okay. Hope this is also clear, right, okay. So these are the things. Now see, if carbon is having like this, so you should call methyl carbon anion, okay. Now carbon having 2 hydrogens, any other carbon is attached to this carbon which is having negative charge. If one carbon is attached to the carbon anion, you should call it as primary carbon anion. What is that? So here methyl carbon, like this it is there. So what is this? How many carbons attached to this carbon? 1. So you should call it as primary carbon anion, okay. Next thing is, please follow this very carefully, very easy to understand. Do not scare first of all, okay, or do not take it light that we can't do this, so let's leave it. Do not think like that. It is very easy. Even your bio part will be maybe difficult than this. It is very easy, just listen here to me, okay. So now this carbon attached to 2 other carbons directly now. So now how many carbons? 2 carbons attached now. So you should call it as secondary, 2 degree, okay. Now if all the 3 valencies of central negative charged carbon is satisfied with the other carbon atoms, then you should call it as 3 carbons attached, so 3 degree tertiary. Like this we have 3 types of carbon anions: primary, secondary, tertiary, and this is a normal methyl carbon anion. So 0 degree here I can say, but there is nothing like 0 degree, so just consider it as methyl, okay. So now, so tell me this, I am representing a negative charge on this carbon. Now tell me what degree for that carbon. Yeah, so do not get confused here. What I told you, wherever the negative charged carbon is there, to that how many carbons are directly attached? See, this side 1 methyl group, it means 1 carbon, this side 1 methyl group, the second carbon here, and this side this carbon. Do not consider this, just look how many attached directly, 3. So what is the degree of that? So it is a tertiary carbon anion. Is that clear or not? Yes, okay. So now, yeah, those who are in the live session, those who are watching from their home or somewhere else, so just feel free to communicate in the class through the chat box, okay. You can write in the chat box so that I can look into it. If there is any confusion or anywhere or any confusions or anything going wrong, you can just feel free to express. I will rectify it, okay. So now one more example I am giving you. I have CH3, CH2, 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 okay, like this, and here negative charge. Now tell me what is the degree of carbon anion? Primary, because to this how many directly attached? Only 1, so it should be primary. Now if there is a negative charge here, let us consider, here it will be, this one is how many, this one is how many, this is primary as you told, and this one, to this 1 carbon this side, other this side, so it is a secondary carbon. That's it, very simple. Similarly we have carbocation and its classification like this. That's why I am explaining here itself, okay, and free radical and its classifications, okay. Next, here stability of carbon anion. So now what are these? Carbocation, carbon anion, free radicals are intermediates, I told you, right. Now during the reaction they may form in between the reaction, okay. So now that intermediate has to be stabilized, right. Now in order to form a product from that, it has to be stabilized, right. Now so now how it will be stabilized? See, carbon having negative charge, okay. So something like this, some R group is there here. So carbon is having negative charge. See, carbon is having negative charge means a person is having some weight on his head, consider like that. Now this charge, if someone takes from him, he will get relaxed, he will get stabilized, you can understand. It means this R group must be something which drags that negative charge from him, right now. Therefore, it will be stabilized. So, carbon anions are stabilized by electron withdrawing group. If some group is there here that is withdrawing electrons from the carbon anion, then that can be stabilized. Yes or no? See, electron releasing groups will increase the electron density on the carbon. It means what? See, I have something like electron releasing group here and negative charge here. I am writing like this, and one more electron withdrawing group here, carbon negative, like this. Okay, look at here. Already negative charge is there. Already huge weight is there on his head. Now again this fellow is also releasing electrons into that carbon. Now what happens? The electron density will be more, right now. Therefore, the system becomes unstable. So what I am saying is, electron releasing groups will increases the electron density on the carbon and it will make it unstable. Okay. In the other case, if we have an electron withdrawing group, what it will do? It will drag this negative charge through the sigma bond towards itself and stabilizes the carbon by dragging this negative charge. Yes or no? So second statement, look at here. Electron withdrawing group will decrease the electron density at the carbon and make it more stable. Okay. So now what is this decreasing and increasing? See, if this carbon is having sufficient number of electrons, it will be stable. But here, due to the negative charge, so more electron density I can say now. So if it is like having more than the requirement, the electron density is more than the requirement. So what happens now? It will destabilizes. So someone helping by taking that negative charge towards them, it will be stabilized. That's what electron withdrawing group will do here. Is that clear or not? Yes. So why I am saying this again and again? So now question, I will make a question here so that you will get some clarity. See here, CH2 negative charge I am writing here and one chlorine atom here. I am writing it like this. Okay. And next one is CH2 negative charge, one fluorine atom here. Okay. And next one CH fluorine here and negative charge here. Otherwise, just look at here. Just consider these two examples, that is more than enough for now. So look here, we know carbon, both are having negative charge, carbon anions. Now out of these two carbon anions, which is more stable? 1 or 2? How we can say 1 or 2? Otherwise, here you take some, okay, chlorine, bromine you take. Tell me, in this case. Even first case also fine, but understand here in a better way. So now, see, here we have chlorine, bromine. Fluorine, chlorine, bromine belongs to same group elements, right now. Down the group, what happens to electronegativity? Decreases. Electronegativity decreases down the group, right now. Okay. So it means which is more electronegative? Chlorine or bromine? Chlorine is more electronegative than bromine, right now. So if it is more electronegative, the bonded electrons are taken towards the electronegative atom. So now tell me, which is taking these electrons? This one is taking nicely or this one? Who is effectively taking? The electronegative atom will drag this negative charged electrons towards itself more easily, effectively. So which is more stable? This one. Is that clear? Okay. Now I am giving you one more question to this. Along with these two, add one more option. So having CH2 negative charge attached to a methyl group. Now arrange them based on the like stability order. Stability order I want. So which is, see, what we require in order to stabilize a carbon anion, electron withdrawing group is required. Electron withdrawing group is nothing but the group which drags the electrons towards itself. Okay. So this fellow will drag electrons more effectively, or this fellow or this fellow. Who will drag? Chlorine is more electronegative, so that it will drag the electrons towards itself more effectively. That is clear. Okay. So I can say one is more stable. Okay. And between bromine and carbon, which is electronegative? Again bromine only, halogen only. So 2, and least stable is this one. So 3 is least stable. Is that clear or not? Right, yeah. Yeah, if it is clear, just tell me clear in the chat box. Yeah, so let us move forward with few more examples. Yeah, so next one is, what is the next one? Carbocation. So carbocation means what here? See, just now you have seen methyl chloride. If we remove this chlorine, so you are going to get this positive charge like this. So carbon with positive charge. It means how many electrons are there here? See, carbon, 3 bonds, 1 bond, 2 bond and third bond. 3 bonds are there with a positive charge. It means one vacant orbital will be there. Okay. So what is the hybridization of this carbon here? So how many sigma bonds are there? 3 sigma bonds. Okay. So 3 sigma bonds, and is there any lone pair or non-bonding electrons? No. So 0 lone pairs or 0 non-bonding electrons. So I can say only 3. So 3 means sp2. So sp2 hybridization carbon will be having trigonal planar geometry. What is that geometry name? Trigonal planar, like this, a triangle shape you can remember, like this. So okay, so what is the angle here? 120 degrees. What is the bond angle? It is 120 degrees. Okay, like this you can remember. Now tell me whether it is electron deficient or electron rich. Deficient. See, any species always tends to have some 8 electrons in it. Okay, but here how many are there? 6 only with one vacant orbital. Therefore carbocations are electron deficient. They always looks for someone who can give electron to it. Okay, so we can say these are electron deficient. Okay, some other term here we will be using is electrophile. What is that? I will tell you electrophile meaning again. So electro means what? Electron. Phile means love. The species which have affinity or love towards electron is called electrophiles. Now this fellow is having electron deficiency, so it is having tendency to take the electron. So can I say it is electrophile? Yes. Okay. Whereas the nucleophile means, in the previous case carbon anion we have seen, that is having 8 electrons, that is having negative charge, non-bonding electrons are there, so that can be donated to someone else right now. So it is having tendency to donating the electrons, so we can call nucleophile. Okay, I will tell you what exactly electrophile, nucleophile again. Okay, so now is this clear? So this is electron deficient now. So electron deficient species, now look at here. So I have a carbon like this, positive charge. Now it is attached with the one methyl group here. Okay, and here I have CH2 plus and methyl group. For more understanding you just write electron releasing group here, and here electron withdrawing group. Now tell me, out of these two which is more stable? See, these carbocation carbons are having only 6 electrons. They are looking for someone who can donate electrons to it right now. So now this electron withdrawing group, what it will do? Withdraws electrons from others. Okay, already this fellow is electron deficient. Again this is withdrawing electrons. What it will become? Further destabilized right now. So this will be destabilizes, decreases the stability. Electron withdrawing group decreases the stability of carbocations, whereas electron withdrawing group increases stability of carbon anions in the previous case. Okay, so now here look at here, we have electron releasing group now. So now what it will do? Only 6 electrons are there. So this fellow like electron releases, right? So it will releasing electrons this side. So now it will become somewhat relaxed from taking electrons from the friend here, electron releasing group. So what I can say here, electron releasing groups increases the stability of carbocation cations. Okay, is that clear or not? Right. Okay, so now this is the statement regarding these things. What is the hybridization? You should remember sp2, and geometry trigonal planar. Okay, having 6 electrons, so we can say electrophile, it is electron deficient. Okay, yeah. So now stability, what is the statement we can say? Electron releasing groups increases the stability of carbocations, whereas electron withdrawing groups decreases the stability of carbocations. Is that clear from here? In case of carbon anions, what you should say? Reverse of this. Carbon anions are stabilized by electron withdrawing groups and destabilized by electron releasing groups, like opposite to this statement. Okay, yes, yeah. Next. We have third one is free radical. So free radicals are the intermediates for carbon having odd electron. See, carbon, for example here, if you write 4 bonds like this, free radicals are formed by how? Homolytic cleavage. It means out of these 3, like this I have some groups, out of these 3, the 4th bond, one of the bond here is broken into 2 equal pieces like this. So what we are going to get? So we are going to get a carbon with these 3 group as it is, but here we have only 1 electron. So total number of electrons in this free radical is how many? This is now free radical. So 1, 2, 3, 4, 5, 6 electrons are there in 3 bonds, and this is the 7th electron right now. So odd number of electrons are present in free radicals. Okay, whereas in carbocation, carbon anions have even number of electrons, like 6 in carbocation, 8 in carbon anions. Those are having paired electrons. So I can say them as diamagnetic species, those previously studied 2 things. Whereas this one is paramagnetic. This odd electron is there now, unpaired electron is there now. So this unpaired electron make it to be paramagnetic. Unpaired electron is the reason for its paramagnetic nature. Okay, so please try to write the notes also. Yes. Okay, so now here all these 3 things whichever we have studied till now are short lived. They will only stays for sometimes, like something if you are going from one area to another area, from Chennai to Hyderabad if you are coming, somewhere some halt is there during, like via we are coming, like here also intermediate is a short lived species that stays only for sometimes. Okay, yeah. Now here also we have classification, like as we did in the carbon anion, here also carbocations and free radicals also have classification. Now tell me, carbon, now how many electrons are there here? 7. Remember that word, we will discuss again. Okay, so now carbon having like this. Okay, methyl radical I can say, and carbon ethyl radical. Okay, so like this I am writing different possible ways. Like this. So let us say A, B, C, D, these are. So tell me, so here what is the classification I can say? This is generally called as 0 degree or methyl like methyl free radical, whereas the radical carbon is attached with the one carbon directly. So it is a primary primary free radical, and this carbon is attached with the 2 other carbons. So it is a secondary, and here this is attached to 3 directly to the other carbon. So it is a tertiary free radical. Is that clear? Similarly, carbocation case also applicable here. Okay, hope this is clear, right? Yeah, Bobby in the chat box. Good evening, dear. So I hope you are following the class. Yeah. So here now what is my question is, the stability order of this free radicals I am asking. How can you decide the stability order of these free radicals? Okay, so free radical having how many electrons? 7. Okay, so if 8 electrons are there, they are having sufficient number of electron, but here lesser than 8, 7 only. It means now this fellow also required someone who can donate the electrons, right now. So now free radicals are also stabilized by what groups? Electron withdrawing groups or electron releasing groups? The releasing groups. So now I am writing CH2 radical with one electron releasing group here. Okay, CH2 radical, one electron withdrawing group here. So AB, out of these two, which is more stable, tell me? A. Why? Because it is having 7 electrons only. Now if this fellow donates some electrons through the sigma bond, it will be stabilized, right now. But here it will be withdrawing. In the electron withdrawing case, the second case, it will withdraw the electron from the 7, right now. So electron density further decreases, it will become further destabilized. So A is more stable than B, okay, in this case. Now here, look at here, A, B, C, D I have given, okay. So A, B, C, D I have given. Yeah, see, actually we are from Hyderabad. So Bobby, are you there in the chat box? Yeah. So now out of this A, B, C, D, so tell me what is the order of stability? So tell me what is the order of this stability of these compounds? See, just easy it is. Look at here. How can we answer this kind of questions? Now this radical species are having 7 electrons only. Now the attached carbon on atom only, attached species, attached group, you look here. These groups are there now. So what kind of groups they are? Are they having more electronegativity than the central carbon atom? Are having equal? Like that we need to compare. Are having less electronegativity? We need to check. Okay, this is a like general step or primary step. Okay, yes. So now carbon radical and carbon with 3 hydrogen atoms. So remember, these alkyl groups are there, na, this methyl group or any other groups. I am saying a word called alkyl group, or we can indicate with a simple R symbol for all alkyl groups. Okay, so these are electron releasing groups. What is these groups are? Electron releasing groups. So now in the case of carbocations or also in the case of free radicals, these are electron deficient only now. So these can be stabilized by electron releasing groups. Therefore R groups increases, the stability also increases. So more number of alkyl groups around this radical. So which is more stable? D. So now tell me the order of the stability. D, C, B, A. Easy only now, right? This will be the scenario in case of carbocations and free radicals. Now what is the case in case of carbon anions? Order will become opposite. Why it will become opposite? Because alkyl groups are what nature? Electron releasing nature. Electron releasing nature increases the stability of electron deficient compounds like carbocations and free radicals, and decreases the stability in case of nucleophile like electron rich species like carbon anion case, because already it is having negative charge. If this fellow is also releasing electrons, what happens to the negativity? More it is, electron density is more, therefore electron its stability decreases in case of carbon anions. Okay, so here I am writing a conclusion here. So in case of carbon anion, what I should say? 3 degrees is least stable than 2 degree, least stable than 1 degree, least stable than methyl carbon anion. In case of carbocation and free radicals, what is the order? 3 degree more stable than 2 degree, more stable than 1 degree, then this one. Is that clear or not? Yes. Yeah. So hope everything is clear here. See, just look for whether it is electron deficient or rich. If the given species is electron deficient, See, if the given species is electron deficient like carbocations, now you just check the adjacent groups whether they are electron releasing groups or electron withdrawing groups. If the given species is carbocation, it is electron deficient. Now, if any electron releasing group is attached, that will stabilizes the carbocation. If it is any electron withdrawing group is attached, that will destabilizes the carbocation. That's it. That's it. This is the way you can able to understand this. Okay? Yes. If anyone are unable to follow it, just go back to the 3-4 minutes back and rewatch it. Definitely you can able to understand. Okay? Yes. Okay? So I request you to listen the class most carefully. Okay? Do not get like I can say like diverted from the class. Okay? So next here, so we have something called carbenes here. Carbene is also fourth intermediate. Okay? This is a fourth intermediate. So here we have, like for example, I am taking this CHCl3. What is the name of this compound? Chloroform. What is that? Chloroform. Okay? So you might be aware of this, chloroform. Okay? So when chloroform is treated with some base like OH minus something like this, what it will do is, it will abstract this hydrogen from the chloroform and it will be, as a proton it will abstract. As a proton means only H plus ion went out. So carbon is having now negative charge with 3 chlorine atoms like this. Right now, after this, one of the chloride ion from this 3 will goes out, because chlorine atoms are having how many electrons? Each is having like this pair of, like 3 pairs of lone, 3 pairs are there like this, non-bonding electrons like this right now. So there will be repulsions between the negative charge carbon and this lone pair electrons of chlorine. Therefore what happens is the bond will be taken towards the electronegative atom and it will goes out as a chloride ion, Cl minus. So what is the remaining species we have? CCl2 like this. Okay, CCl2 we have, and see we have a negative charge here, I am writing negative charge here, and if this goes out, one orbital is becoming empty right now. So like this, one empty orbital I am writing. Okay, so now I can indicate like this. There are 2 ways to indicate this. In one orbital, negative charge is indicated with one orbital as empty orbital. See, the negative charge is nothing but a pair of electrons right now. So I can indicate these 2 electrons in one orbital like this, CCl2, and the other way is I can indicate one electron in one orbital and other electron in the another orbital, instead of indicating it as empty. Okay, if we put both electron with opposite spin in single orbital, in one orbital, you should say it as singlet carbene. What is that? Singlet carbene. If you put one electron in different orbitals, you should call it as triplet carbene. What is that? Triplet carbene. This is the simplest way you can understand this topic. Okay, I hope you got what exactly singlet and triplet. Okay, so how we are saying this word singlet and triplet? This is called multiplicity, spin multiplicity of that electrons in the compound. See, spin of one electron is how much? Spin of one electron is either plus half or minus half, either clockwise direction, anti-clockwise direction. Okay, so now when I say multiplicity, you should use this formula. Multiplicity is equals to 2s plus 1. So this is a spin multiplicity formula. Okay, so now here in the first case I kept 2 electrons in one orbital now, so it will become 2 into both electron with opposite spin. Opposite spin means one is with plus half, another one with minus half. So overall value becomes how much? See, plus half, minus half, plus 1. So minus half plus half is removed. So it will be 0, 0 into something will be 0 plus 1. So what is the value you got? Multiplicity value as 1 you got. That's why what is the name of that compound? Singlet. Okay? Yes. Yes. Yeah. So the other one is here singlet is over. Triplet, when I will say triplet, see 2s plus 1 I have. So here 2, what is the spin here we have? See, both of them have same spin in different orbitals. So both you take it as either plus half or minus half. So let us say I am taking plus half. Both of them have same spin, so plus half plus half. So half plus half, it will be 1. So 2 into 1 plus 1, it will be 3. So 3 means you are saying it as triplet. So two types of carbines, one is singlet, triplet, based on the spin multiplicity. Okay, remember this, we will discuss about this again. Okay, so these are also intermediates in some reactions. The examples for these reactions are Reamer-Teamer reaction, RTR in the short form, and Somblate reaction, and free radical substitution reactions, and etc. These are the some simple examples I am giving you. Okay, yes, yeah. Over. So now what we have studied, till now we studied about like this. We have studied something between intermediates we have studied. What is that? Intermediates. Now we need to know this side what we have. So this side we have something called substrate plus reagent gives intermediate or transition state that gives us final products plus byproducts I told you. So intermediate we have studied carbocations, free radicals and carbon anions. Okay, up to these 3 and carbons also 4 we have studied. Okay, now we need to study about these reagents. Understanding the reagent and substrate is very important in order to start your reaction. Where exactly reaction is taking place, how can you able to identify? By looking at substrate and reagent. These are the starting materials. So now a reagent generates 3 types of attacking species. So this reagent generates these types of attacking species. One is called electrophile, other one is nucleophile, other one is free radical. Okay, we have studied 3 terms. What is that? Electrophile, nucleophile, free radical. So those reagent will go and attack on this substrate. Okay, very simple, just follow for few minutes, it will be done. See, I am saying you to follow because this is not done within some 30 minutes or like some 15 minutes. Actually it should be studied for like at least for 5-6 classes. Okay, I am trying to give you with very minimized way in a very crisp and clear manner. Okay, just follow for few more classes so that you can answer any type of question. See, I have seen IIT BT paper already. I have analyzed it where the questions are purely conceptual. In order to understand, in order to tackle those questions, you need to know these basics first. If I directly take 1 or 2 questions here and if I answer them, I may be okay, but you won't feel satisfied when you answer other questions. If I solve them with some numerical trick, that will be feel good in the class, but after if you apply that question or that concept to other question, it won't work. So that's why I am giving complete basic concept first, so that you can able to do any type of question. Okay, right. Next. So what is an electrophile? So I told you that electrophile means what? Electron, phile means love, affinity. So the species which have affinity or attraction towards electrons is called electrophiles. So generally who will have attraction towards electrons? If it is electron deficient, therefore it requires electron, so that fellow will look for the electrons, right now. So I am saying electrophiles are electron deficient, which can accept a pair of electrons. Okay, right. Yeah, so now see, these electron deficient species are two types. It can be positively charged or it can be a neutral electrophile. So positively charged means what? Just now we have studied about carbocation. So tell me here, carbocations have how many electrons? Carbocation, carbon have how many valence electrons? 6 it has. It means in order to gain its octet 8, it required 2 more electrons required. So now it is lesser than the required right now, only having 6 but required 8. So I can say carbocations are what? Electron deficient. So having positive charge. So these are electrophiles, examples of electrophile, especially positively charged electrophiles. Is that clear or not? Yes. Okay. Now look at here, I am writing iron with some +3 charge. Now it is also having positive charge. Yes or no? This is also electrophile. Okay. Now hydrogen I am writing with a positive charge. It is also electron deficient. Why electron deficient? Hydrogen atomic number is 1. It means 1s1 electron is there. Okay. So this electron is removed so that it is becoming H plus, like a proton we are saying that 1s orbital become empty now, right now. So now it is ready to accept a pair of electron from others. So that is also electrophile. Okay, this is about positively charged electrophiles. Now let us look into neutral electrophiles. See, neutral here, neutral means, for example, I am writing BF3, boron trifluoride. So how the structure looks? Boron, F, F and F, like this I am writing. Okay. Now boron is having empty orbital here. Now just count how many electrons are there. 1, 2, 3, 4, 5, 6. Right now. So 6 means less than 8 electrons. One empty orbital is there with the boron. So it is ready to accept a pair of electron to this empty orbital. So I can say boron is also boron trifluoride is also example of electrophile and especially neutral. Like there is no charge, so it is a neutral electrophile. Is that clear or not? How to identify neutral electrophiles, positively charged and negatively charged? Okay, is this clear? See, that is also good question you are asking. Yeah. So first tell me what is the boron atomic number? 5. Okay. So write its electronic configuration 1s2, 2s2, 2p, 1. So these are the valency electrons which participate in the chemical reaction. So I am indicating them with some orbitals like this. Okay. So how many valency electrons? Here 2, here 1. Okay. So one of the electron from here will excites here. Why it excites? See, in order to form BCl3, each chlorine or BCl3 or BF3, whatever it is, okay, so each halogen required one unpaired electron to pair up. Right now, here it is having only one unpaired electron. For one fluorine is fine, but 3 are there now. So each one required one electron. So one of the electron from here excites to this site, so that you are going to get orbital something like this 1, 2, 3, 4. So one orbital here with one electron. See, this is jumping here now. So you have some 3 electrons like this. Is that clear? Okay. So now one chlorine will pair up with this, another chlorine will pair up with this, and another chlorine will pair up with this. Chlorine or fluorine, whatever it is. Okay. If I mention chlorine, fluorine, you mention only fluorine here, like this, in order to form BF3. Okay. Now look here, we have an empty orbital, but there is no positive charge. It is just a empty orbital. So we need to represent that empty orbital only. Vacant orbital is there now. So to that it will tries to like gain the or accept the electrons right now. So I can say BF3, these are neutral electrophiles. Okay. Now up to here it is clear now. Up to here it is clear now? Yeah. See, now what is the use of studying this? We should able to understand that. See, I am writing something like this, okay. So, if you look at the questions of IIT JAM or GATE, you will be scared by looking at the structures if you are really new to this, okay. So, it will be looks something like this, okay, and some more thing I am writing one more thing here, like this I am writing, okay. So, now identify, I have a nucleophile here. What do we mean by nucleophile? It has electron density, I will explain this, but listen. So, these two, like this is the reagent that should attack on this given compound. Where it will attack? That is my question. How can you decide? See, you need to look at this carbon and this carbon. Why? Because those are only the reactive sites. Okay, so how we are saying those are reactive sites? See, there are pi bonds, here also pi bonds. Right now, we know pi bond and remaining positions are having sigma bonds. Okay, we know pi bonds are weaker than sigma bonds. So, it means we can expect a reaction at these pi bonds generally. This is the general approach. Okay, so now out of these two pi bonds, where this nucleophile attacks easily. So, wherever more electron deficiency is there, see, more electron deficiency means that fellow required electrons easily. Right now, see, if this is more electron deficient, he is really looking for electrons from someone. So, it will allows that to attack on him easily right now. Okay. So, look here and compare which is more electron deficient. See, here this adjacent carbon is there now. So, adjacent oxygen is there now. So, these electrons will donated into this orbital of carbon when this pi bond is shifting this side. Why it will shift like that? Because carbon, oxygen, which is electronegative? Oxygen. So, the pi bond here will be dragging towards oxygen, here also dragging towards oxygen. Both carbons are having partial positive charges like this, but which is having more positive charge, here or here? That is my question. So, that will be understood when you analyze what are the other surrounding groups. See, here we have surrounding group is oxygen with lone pair. So, to this carbon having positive charge will be normalized or neutralized by with the help of the lone pair electrons of this like neighboring oxygen. So, that is called resonance or conjugation, which we are going to study later. Okay, but here there is no such kind of donating site. Therefore, which is more electron deficient? This one. More electrophilic site is this one. So, nucleophile attack at more electrophilic site. So, therefore, this will attacks here. That's it. See, this is how the first step takes place in a reaction. Understanding the exact site, where do we need to initiate the reaction, here or here? This is the primary step. Okay? Yeah, hope this is clear how you are able to understand what is the importance of electrophile and nucleophile. Okay? So, more electron deficient, that will be more reactive with the nucleophile, or more electron rich that site, that will react more readily with the electrophile, like this. Okay? Yes. So, nucleophiles means what? These are nucleo, it means nucleus, phile means love. The species which have love towards or affinity towards, attraction towards nucleus, it means positive charge. Okay? If they have, the species have affinity, attraction towards positive charge, we can say them as electron rich, because electron rich means they have negative charge on it now. Like, see, all of them are having some negative charge up to here, and these fellows are neutral, but they have non-bonding electrons here, like this. So, nucleophiles are two types again, either negatively charged or neutral. So, if they are neutral, they should have some lone pair electrons or non-bonding electrons, then we can consider them as nucleophiles. Okay? So, this negative charge will go and attack at this, the electron deficient side, that is nucleus of the other group or atom. Okay? So, during a chemical reaction, just identify electrophile, nucleophile, do a reaction, that is it. Okay? Now, I will give a basic idea here. See, the first reaction we have started something like this, okay? Now I am giving you one nucleophile here, like this. Okay, so tell me, what is the reaction you can expect here? Halogen, X is some halogen, chlorine, fluorine, chlorine, bromine, like that you can consider. X is anything out of these three. Okay, now tell me, carbon is more electronegative or halogen? Halogen. See, R group is considered alkyl group, carbon, carbon only, so there is no polarity, there is no disturbance between them. But there is a disturbance here, right now. So which bond is easily breaking here? There is a chance of breaking the bond between C and this X, halogen, right now. So since it is more electronegative, bond cleavage will be heterolytic, one side. Okay, now what it is creating on this carbon? Positive charge or negative charge? Positive charge. Now what is a suitable thing to attack on this? Some nucleophile, nucleus loving species are required. Therefore, this species, this negative charge will come and attacks here, that's it. You are done with your reaction. So you are going to get RCH2, some nucleophile here. Okay, simple. Identifying electrophilic site, attacking with the nucleophile, or identifying nucleophilic site, attacking with the electrophile is your duty during the organic reactions. That's it. Okay, yeah. So next thing is, see, tomorrow's class might be in the app I will be taking only for those who are joined with the CBC, okay, in the Chindu biology classes, that will be in the app, okay, yeah. So look at here. So tell me for this, these are very basic first, okay, answer these questions. Yeah, got any answer? First one, undergoes homolytic. See, they are saying this species, they are saying condition is mentioned, homolytic cleavage. It means you should break the bond equally. So break it like this. So you are going to get something like this. Dot, no, not like that. Something like this, dot and dot here. This is having negative charge. So your option 1 should be correct. Next one. Octet, complete. Octet means 8. In which case it is having 8 electrons? Huh? Carbon, how many are there? Singlet, triplet, I told you. How many? Only 6 electrons are there. So carbocation 6, free radical 7, carbons are 6. So carbon anions are 8. That negative charge, isoelectronic with ammonia, I told now. So it is having how many? 8. Okay? Yeah. Like this you can able to follow. Okay, next. Here again we studied about these carbons now. So I told you one is singlet, another one is triplet. So in singlet case both electrons are paired, whereas in triplet case both electrons are having same spin. So since they have same spin, both are unpaired electrons. So triplet is paramagnetic, singlet is diamagnetic because electrons are paired. So carbocations are diamagnetic, carbon anions are diamagnetic, carbons, if it is singlet diamagnetic, triplet paramagnetic, and free radicals are always paramagnetic. 7 electrons are there, right now. Right now. So based on this you tell me for answer for this. Diamagnetic. So diamagnetic they are asking. Okay, carbocation how many electrons? 6, all of them are paired, so it is dia. Carbon anion 8, all electrons are paired, it is also dia. Singlet carbon, dia only we have seen like this, so it is also diamagnetic. So option number 4 will be your answer. Next, unshaded pair of electrons is contained by. unshared pair of electrons. They are saying unshared pair. Okay, so just try this. Next one, identify electrophiles here. So those who are in online, just take the screenshots of these, and I want answers for them in the comment box. So these are the questions, take them as a screenshot and try this. This is from JEE Mains, just for understanding purpose. So what do we mean by this ambidentate means? Ambidentate, like if a person is writing with two hands, what we can call ambidextrous we are saying. So this is ambidentate, means what? That nucleophile has a nature of forming bond with this side and also the other side. Okay, it has like either of the sides right now. So nucleophile can able to form from both sides, then we can say ambidentate. Okay, so now here when I say NO2 minus, okay, look at here, nitrogen having one oxygen like this and one lone pair here like this. Now nitrogen can form a bond from this side using its non-bonding electron or using this negative charge. Now I can say nitrogen is a ambidentate ligand. Okay, like this. You need to identify from the four options. Okay, next. Yeah, so this I hope you can easily answer this question. So tell me, carbocation stability order. So this is the last question of the session. Remaining we will see in the next class. Tell me fast, what type of carbocations these are? First, identify them. Like classification we have now. Like that. Tell me, this one is primary, this one is here, this one secondary. Now tell me which is more stable? 3 means B, secondary, primary. So BCA. Fourth option, easy only? Yes. Okay. So this is about the session. I hope you really enjoyed the session, and if you are new to this channel, please click on the like button as well as subscribe button so that you will get daily updates from us. So thank you for watching. Stay connected with us. Thank you.